So we are going to look at trig identities. So these are things that are given to be true. So we are going to learn the identities and then use the identities to prove certain equations are true. So here are the basic trig ratios, the reciprocal identities. So sine is 1 over cosecant, cosine is 1 over secant, tan is 1 over cotan. And remember, we used these whenever we were doing the calculator applications. And then cosecant is 1 over sine, secant is 1 over cosine, cotan is 1 over tan. And then our next section is the trig or the quotient identities. So tan is sine over cosine. And this is, remember, sine is y, cosine's x, and tan is y over x. So instead of putting y over x, we're putting sine theta over cosine theta. And then cotan is the inverse. So we can use these properties to help us. And then the next part is the Pythagorean identities. So think Pythagorean theorem. And what these all have in common is they all have squared powers. And then all have 1, have a value of 1. Okay. And what we are going to do is we're going to use these to replace in a problem. So we're given this sine squared theta plus cosine squared theta equals 1. We can rearrange this by doing some algebra, and I could subtract the cosine squared theta on both sides, and then we have sine theta squared equals 1 minus cosine squared theta. Or I could solve for cosine by subtracting the sine squared theta. Okay, so this one identity will give us 2 more. It's just rearranged. And the reason we want to do that is so we can replace it in a problem. So it depends on what they have in that problem and how we want it to look. So if we want sine squared theta, then we would solve it for sine squared. Or if we want cosine squared theta, we'd solve it for cosine. Okay, and then with tan and secant, here's one of the identities, but then we can rearrange it. Let's say we want to solve it for 1. So we'd have secant squared theta minus tan squared theta. Or we could solve it for tan squared theta by subtracting 1 from secant squared theta. Okay, let's go. Let's say we have cotan and cosecant. We could solve for 1 by doing cosecant squared theta minus cotan squared theta. Or we could solve it for cotan squared theta, and then we have cosecant squared theta minus 1. So all we're doing is basic algebra to solve it for a particular trig function, or for 1. All right, so let's do these examples. So it says use trig identities to transform one side of the equation into the other. So what we want to do is we want to prove that the left side equals the right side by rearranging, by exchanging, and by replacing. So let's look. Cosine times secant equals 1. So if we look at our identities, usually I want to replace for sine and cosine. So if we can, we want to put in terms of sine and cosine. Okay, sorry. All right, so we have cosine. So let's look at what secant is. So let's go to these identities. All right, I see it right here. Secant is 1 over cosine. So I'm going to keep this one, and I'm going to replace secant with 1 over cosine theta equals 1 question mark because I want to prove that it does. All right, you multiply and these end up canceling, and we get 1 equals 1. So we just proved that that is true. Okay, let's go to the next one. Tan theta cosecant theta equals secant. So remember how I said we want to put it in terms of sine and cosine. So let's look at tan. I'm going to go up here. Tan is, tan is 1 over cotan, or actually let's use this one, sine theta over cosine theta. So that's what I'm going to replace tan with. Sine theta over cosine theta. Okay, then I'm going to look at cosecant. What can I replace that with? Go up, and I can replace it with 1 over sine theta. So that's what I'm going to do. I'm going to put a question mark there, secant theta. All right, whenever you multiply, we could simplify these guys out, and I get 1 over cosine theta equals question mark secant theta. All right, so let's see if we can exchange 1 over cosine theta with something. So go up here and look for 1 over cosine theta. Oh, it's right here, which is secant. So I'm going to go back down. So this can replace with secant theta. So now look, secant theta equals secant theta. So we just showed all our work to prove it was true. So this is going to be part of the problem, is showing your work. You can't just put a check mark and say, yeah, that's true. You have to show it. All right, let's look at the next one. Secant theta plus tan theta, and then times secant theta minus tan theta equals 1. All right, we have to do multiplying binomials. So let's go ahead and multiply. Secant squared theta is that, plus secant theta tan theta. Oh, that would be minus, actually. Let's fix that. And then the next one would be plus secant theta tan theta. And then minus tan squared theta equals 1. All right, all this is difference of squares, because those middle terms will cancel out, and we get secant squared theta minus, my pen doesn't want to, right, there we go, minus tan squared theta equals 1. Okay, so let's look and see if we have any of those as our identities. Since we have a plus or minus, we are going to look at our Pythagorean identities. Oh, and also because we have the squared. So see if we have that somewhere. And we do. We have it right here. So 1 equals 1, and it is true. Oh, I should have had question marks there. Okay, so it just takes a little bit of time. You're kind of piecing together puzzle pieces. All right, let's look at the next one. This is division, but we have addition between them. So we want to kind of break this down. So I'm going to break it down to be tan theta over tan theta plus cotan theta over tan theta. And then I'll keep the cosecant squared theta. All right, tan theta over tan theta gives us 1. So 1 plus, let's go ahead and keep this, cotan theta over tan theta equals cosecant theta squared, or squared theta. All right, so 1 plus, I'm going to break this up to be cotan theta times 1 over tan theta. Just knowing basic algebra principles. Okay, and then I'm going to look at, oh, you know what this is? This is really cotan theta. So then this whole thing would be 1 plus cotan squared theta equals cosecant squared theta. Okay, Let's see if we have that as part of our Pythagorean identities. And it would be this last one right here. Let's see. Oh, it's actually this, right? So that says cosecant squared theta equals cosecant squared theta. And these should all have question marks. All right, so that proves it to be true. All right, so we are going to continue to talk about this in class and do some practice problems.